Hello, we are the data team and the paper we choose is called Explainable Machine Learning in Credit Risk Management and is written by Busman, Judici, Marinelli and Peppenbrook, who published it in 2020.
The paper aims through an artificial intelligence model to manage credit risk, in particular the risks that arise when using peer-to-peer lending platforms. The model applies correlation network to place values so that the model predictions are clustered according to the similarity in the underlying explanations. In this model, similarity networks are used in a post-processing phase in order to interpret the predictive output of the model. This achieves predictive accuracy and explainability. Explainability means that a stakeholder can understand the key drivers of a decision based on the model. Credit risk models are typically used to estimate the expected financial loss suffered by a lender if a borrower defaults on a loan. Alternatively, credit risk can be measured with artificial intelligence models capable of extracting non-linear relationship between financial information contained in balance sheets. Normally, in a credit model, for each company, a response variable is defined to indicate whether or not the company has default on its loans, with values of 1 and 0 to indicate whether it default or not default. Credit rating models assume that the response variable can be affected by explanatory variables. The advantage of using shaped values over alternative explainable artificial intelligence models is that they can be exploited to measure the contribution of each explanatory variable for each point prediction of an artificial intelligence model. Shapley values were originally introduced as a solution concept in cooperative game theory. They correspond to the average of the player's marginal contribution associated with all the possible orders. The model present in the paper uses a minimal spanning tree, MST, which is a tree with all cycles of a complex network which joins pairs of vertices with the minimum total distance.
In highly regulated sectors such as finance or medicine, models that balance accuracy with explainability must be chosen. In step 1, the authors improve the selection of models based on their predictive accuracy and use then an algorithm that achieves explainability. In step 2, they locate and group the position of each company in the sample, which allows an explanation of the determinant of the solvency of each company. In step 3, they propose to calculate the Shapley values associated with each company, providing a tool that can interpret the output of a very accurate artificial intelligence model. In step 4, they estimated Shapley values using Lundberg and Lee-Sharp computational framework to determine which variable to include in the model. In step 5, it was proposed to use similarity networks, defining a metric provides the relative distance between companies by applying the Euclidean distance between each pair. And in this step 6, the minimal spanning tree representation of the companies was derived using the correlation networks method suggested by Mantenga and Stanley. The EMST dual tree Boruca algorithm was used to generate the MST in R. 7. They divided the data into a training set and a test set using random sampling without replacement. In step 7, they estimated the XG-BOST model on the training set, applied the obtaining model to the test set, and compared it with the best logistic regression model. In step 9, the Shapley values explanations of the companies in the test set were calculated. Using the values of these explanatory variables, the tree-shape method was used in combination with XG-BOST.
After the comparison of the XG-BOST model and the best logistic regression model, it could be seen by means of the ROC that the XG-BOST model has higher predictive accuracy, and with the elaboration of the minimal spanning tree, it was possible to show that the groups are quite dispersed along the correlation network. With the development of another minimal spanning tree, in which the nodes are colored depending on whether the corresponding company has default or not default, it was observed that the nodes representing the companies that default appear grouped in a specific area of the network and form clusters. This suggests that these companies form communities characterized by the importance of similar predictive variables. Also suggests that the companies that have a not default but are close to these companies that default have a high risk of defaulting, because the significance of the predictor variables is very similar to that companies that have default.
To better explain the explainability of the results obtained, the estimated credit scores of 4 companies were interpreted: 2 actually default and 2 that is not. This demonstrates the advantage of the explainable model, which can indicate which variables contribute most to the prediction of the default value. The paper even shows how the explanations are customized for each of the 4 selected companies. The model can explain from a substantive point of view any individual prediction in terms of the contribution to the Shapley value of each explanatory variable. Artificial intelligence improves the convenience and accessibility of financial service, but they also trigger new risk. And the paper proposes as future research to extend the proposed methodology to the other data sets, and in particular to the unbalanced ones, for which the occurrence of the defaults tends to be rare.